Hi guys, in today's video we're going to be doing a simple chemical reaction. It's a demonstration, not the kind of thing that you get the kids doing themselves, but it demonstrates to the kids something about the variables that affect a chemical's likelihood to undergo a reaction. So the particular mix of chemicals that I'm using in this case is a store-bought coffee creamer that is in fact highly flammable, though it doesn't say it on the box. Now, because we're doing ultimately a combustion reaction, a flammability reaction, you want to take a couple of safety procedures, precautions rather. So you would like a couple of heat-proof mats just to do this over, a fire blanket, and a fire extinguisher on standby just in case. However, very low risk and it's perfectly safe to do. Now, I say that this is highly combustible, and it is in the right circumstances. However, if I just take a little bit of this here and try holding a flame up to it, clearly nothing happening at all. Okay, it starts to blacken a little bit, but that's about as bad as it gets. However, if I do exactly the same thing, take pretty much the same quantity, but drop it over the flames, we immediately see that it is, in fact, flammable. So why is this the case? And you can get the kids to talk about it, and I've actually found that in the past, obviously you can do it larger scale as well, and that's more entertaining. Oh, look at that, super. So you do it larger scale as well. I find that the kids very quickly actually come up with the answer, which is pretty awesome. So the reason for it is basically particle size. In bulk form, such as this, there's not enough oxygen getting to it. What we're seeing here is a chemical reaction. It's a chemical reaction involving the actual chemicals within the coffee creamer and oxygen in the air. And the short version is we haven't got enough of the oxygen in the air getting to this at the moment. We've only got the outside of it that we can actually get to. However, when it's dropped, like so, it's a different matter because all the particles are exposed to the air, there's oxygen all around them, and that gives them the fuel that they need, or the oxygen that they need to actually combust. So that lets us know that the size of particle plays a significant role in something's likelihood to react. And we see this across lots of different chemical reactions. Metal filings dissolve much faster in acid than lumps of metal in the acid, for example. And there's countless small twigs in a fire burn much faster and much easier than throwing a whole log on there. So it's got some real world applications as well. We can get them thinking about how variables, how different variables can affect different chemical reactions. Similar sort of thing applies to dissolving as well, and if you haven't watched the dissolving video yet, basically the same principle except this is with burning instead of dissolving. But particle size definitely makes a difference in lots of different areas when it comes to chemistry, and this is just another example of that. Fun demo, the kids absolutely love it, and as long as you take the correct safety precautions, it's perfectly safe to do. So give it a shot. Cheers!